We got a new term, new chapter. It's kind of like starting fresh, and I am excited for you, and I am excited for chapter 3. So, graphing linear functions. We're going to talk about functions. We're going to talk about linear functions, function notation, graphing linear equations in standard form, and graphing linear equations in slope-intercept form. So I'm excited, and we will just get started. Okay, so chapter 3.1, functions. I just put this up because this is how our brain functions, get it? Yeah, okay. All right, so there's kind of a lot of vocabulary in this section, so you might want to get out your notes and pause when you have to so that you can get these things written down so you can use them. Okay, a function is a rule that establishes two quantities called the input and the output. And I promise it's not, this sounds a lot more difficult than it really is. Okay, the input is what you put in, then a rule happens to it, and it is kind of like it's transformed into the output. And so whenever I think of a function, I'm not kidding, I think of one of these Play-Doh things. Did you ever have one of those? You put the Play-Doh in like in here, and then you squash it, and then out comes the Play-Doh, and it looks like spaghetti, or maybe it comes out like a big long star. You know what I'm talking about. It has like a mold. That's what I think of. In goes the Play-Doh, we do something to it, and it comes back out, only it's different. Okay, so when we're talking about for each input, there's exactly one output. I also think of a soda machine. So if you go to a soda machine and you push a button, you're going to get something out, right? So your input is the money and pushing the button. And the output is your drink, and you're going to get one soda. Okay? Now my son, it seemed like when he was little, whenever he pushed a button on one of these machines, he would get 2 drinks. And so if that happens, then it doesn't function. Get it? It doesn't function? Okay. Anyway, so 1 push, 1 drink. Okay? But what if we have something like this? I'm pushing 1, but I have different things I can push to get 1 drink. I can push this for Mountain Dew, and that one, and that one. Or no, that's the Sierra Mist, sorry. But I can push either one of these for Mountain Dew. But it doesn't matter. These could all be Mountain Dew. It still works where when I push the button, only 1 comes out. Okay, so we are going to determine whether each relation is a function. Okay, our input is the x value, our output is the y value. So I'm looking here and I've got -2 is going to 2. -1 is also going to 2. That's okay. That's like pushing different buttons but getting the same drink. Okay, 0 is also going to 2. So I've got 3 buttons for the same drink. 1 goes to 0 and 2 also goes to 0. Okay, so if we wrote this in another way, we could write -2, -1, and 0 all go to 2. Okay, and over here I have 0 and 2, and they both go to 0. All right, but like I said, it's okay for them all to go to the same thing. It's like the buttons on a soda machine giving you the same soda. Okay, but let's look at this one. Okay. Oh, I want you to try this one. All right, so go ahead and pause the video and give it a try. Okay, so let's look and see what we've got. We have -5 going to 0. We have 0 going to 0. We have 5 going to 0. But we also have 5 going to 10. Okay, this would be like if I push the button and I got 2 sodas coming out. This should be pointing up here. And I got 2 different sodas. Okay, so this is not a function. Okay, let's try another one. So here I've got 4 going to 0. I've got 8 going to 7. 6 is going to 4. 4 is going to 3. And 5 is going to 2. This is definitely a function. For every input, I have exactly one output. And that's been true for the other ones also that are functions. Okay, so go ahead and I want you to try this. So go ahead and pause the video. Okay, so let's look at this. We have -4 going to 8. We have -1 going to 2. We have 2 going to -4. And 5 going to -10. So yes, each input has exactly one output. Okay. No, I can get this in. Okay, so here's my input. Let's look and see it from this angle, or from a table anyway. I got -2 going to 3, -1 going to 4, 0 is going to 5, but 0 is also going to 6. Okay, so this is not a function because 0 is going to both 5 and 6. I could cross that 0 off and rewrite it like this. So it is not a function. All right, so here's one for you to try. So go ahead and pause your video and give it a try. Okay, this one's pretty straightforward. 2 is spitting out 2.6, 4 goes to 5.2, and 6 goes to 7.8. So they all have an input going to an output. All right. So this one, determine whether each relation is a function. Okay, I have -1 going to 4. I have 3 going to 15. I have 11 also going to 15. This is okay. One input gets one output. One input gets one output. I know that this looks like I have to push 2 buttons to get 1 soda. It looks like that. But we could also rewrite this like that. We could write it like that too. Okay, so 1 is going to 4, -1 is going to 4, 3 is going to 15, and 11 is going to 15. Okay, so try this one. I'll just go ahead and think about it, pause, think about it for a second. So we have 1/2, and it is going to -2, and 0, and 4. So this would be like if I pushed a button and I got 3 different sodas. So this is not a function. So not a function. Okay, I am going to stop the video and we will continue with the next one.